So welcome everyone to our next OISF, oh my goodness, OISF webinar. We're actually calling this a hands-on session as there'll be a lot of demonstration and hands-on activity by our presenter today. With us will be Eric Leblond, introducing you to the Suricata Language Server. So how to write better Suricata signatures faster. Before we get started, as always, this webinar hands-on session is provided to you through the OISF and Suricata. OISF is the Open Information Security Foundation, US-based 501c3 that supports the foundation, supports all of the development, all the activities around Suricata. So if you're interested in helping out more, most of the development is funded through contributions. So you can look at consortium membership, Suricon sponsorships, more, visit oisf.net or just simply send an email to info@oisf.net. If you haven't, consider joining our forums, forum.suricata.io. That is where most of the community is connecting now, asking questions, posing issues, just having general discussions. So please check that out. I was in the process of updating a link. I forgot to do that. But once I get done talking, I'll post a link in chat. We also have a Discord, and we encourage you to, if you have any discussion today for the live event, to direct that to the Discord. But I'll get that link in here in just a moment. Briefly mentioned Suricon. Suricon is, although it feels like it's a ways off, it is just around the corner. This year is in Athens, Greece, not Athens, Georgia. So join us November 9, 10, 11 at the Grand Hyatt in Athens. We'll have, as Suricons in the past, a couple of days of training before Suricon. So what would that be? The 7th and the 8th, and then the 9th, 10th, and 11th will be the Suricon conference proper. More information, suricon.net. And without further ado, our presenter today will be Eric Leblond. He is part of the OISF board and a developer, as well as Stamus Networks, CTO, CEO, COO. I don't remember, Eric, you'll have to introduce that. If you have any questions for Eric, please feel free to drop those into the chat. Again, if you're set up with Discord, we'll be monitoring that and would prefer it just because it's a little bit stickier. If not, please feel free to use the Q&A feature in Zoom, and I'll just manage those throughout the session. So Eric, welcome. Thank you for joining us today.
Hello. Yes, let me share my screen. Share. So, okay, so you should see the screen now. You see the cat. Yes, okay, perfect. So Eric Leblond, I'm the CTO and one of the co-founders of Stamus Networks, also as mentioned by Josh, board member of OISF, and also a developer of Suricata, and sometimes I do some other stuff, which, for example, developing a Suricata Language Server, and I'm going to talk to you about this today. So, okay, so just a small intro on Stamus Networks. It's a company that has been founded in 2014 by Peter Manef and myself. We have headquarters in the US and in Paris, France. We are big open source fan on the side of Defender. So we have a lot of tools that can be used to improve your defense. We've got Cells, an open source Suricata distribution, GopherCap, a Splunk app that can be used with Stamus product on Suricata. And recently we did add the Suricata Language Server to the list of open source software we have. And we are selling we have a commercial solution, Stamus Security Platform, that is a Suricata-based IDS on NDR solution. So if you want to install Suricata and get all the data without the need of administration, and you want a lot of layers on top of Suricata, you can ask a demo and I will explain you what we are doing. But I'm not here to talk about this. I'm here to talk about the writing Suricata signature. So yesterday I just went on a tour on Twitter, and then there was this tweet on Suricata, a timeline. Anyone familiar with auto-writes non-Suricata signatures? I'm dying here. So yeah, so I just answered to the guy that I'm doing a webinar the next day. And yeah, so this is known as being complicated to write a Suricata signature, and it can really be a nightmare. One of the reasons is that the syntax is inherited from Snort. In 2008, when Suricata did start, the concept was to be able to use Snort signature, because it's like if you got an engine and nothing to put inside, it will be an issue. So picking snort was language was definitely a good choice at the time. It has evolved since, but we have still a syntax that look a bit like the one from snort. Hopefully we've got some evolution like the sticky buffer keyword that helps a lot when you want to do a bit more matching. But as the syntax is complex, as it is complicated to find what you want to match on, it can be really a repetitive process because you need to write the signatures, check if it is matchings, refine the signature, and we're not even here talking about the syntax. So the way you wrote Suricata signatures is you use your editor, you check the documentation because there is so many keywords, it's almost impossible to remember. You test the rule with Suricata, you fix the rule, you test the rule with Suricata, you get a coffee, you fix the rule, you test the rule with Suricata, and then when it's done, now we are going to talk about rule performance, and then you need to fix the rule once more. So it can be really tedious, so anything that could help here could be really useful. I'm going to do a demo of the old style, and I hope that after this webinar, everybody will switch to Suricata Language Server to fix a little bit this. So let's get a look. So I think like this, it should be a bit better. Okay. So let's get a look at what I've got in this webinar. I've got a pickup from malware traffic analysis, which is definitely one of the best sources of public pickup for threat detection, for threat analysis. And what I want to do is to play this pickup, replay this pickup, extract some data, and then write a signature based on this. So I can just, okay, definitely the wrong server. Okay, let me just do that. Okay, so now I should have Suricata, yes. I'm going to read this file and output everything in the data directory, and I don't want any rule for now because I'm going to write some. Which means, by the way, I'm not in the good shell. Okay. Okay, so I do that. I've got one output. So now in data, I've got the infamous f.json file corresponding to this pickup. So let me check. Yeah, okay, so that's not the good one. So it was here. Sorry. Yes, so now let's get a look at this pickup. Not doing that. So let's check to see if we've got some HTTP inside. So yes, we've got event type HTTP and some other things. So let's use GQ and get some more. What I'm doing here, event type, and I just want the HTTP event to see what kind of request we have, just to find something valuable for the exercise. Okay, so now let's say that I want to do a signature based on the HTTP user agent. I will just ask on top of this to just display the HTTP user agent. Every time I make this mistake, come on. Like this. Okay, so now I just have a HTTP user agent. So let's factorize this a little bit to see what we have. Okay, as you can see, now we did extract all the HTTP user agent from the protocol login inside Suricata. So we just did look at the HTTP event. Now we have two strange things, a few strange things that we follow traffic here of the win HTTP user agent, which is not something you can commonly find in the network, like a bit of a test agent. So we are just going to write a signature to alert on this win HTTP. And if we look at a bit more into this, in fact, I wanted to do that. So I will just ask to get the information for event type HTTP for the win HTTP loader. And if we look at this, we have the user agent that is win HTTP loader, and we have the URL that is scene.png. So I will want to match on both because let's say I've done a threat analysis and it looks really bad. So let's start this. So user bin and vim, no, not engine, vim.tiny. So here I've got just a raw vim instance with no Suricata Language Server setup, and I will create in http.roles. Okay, yep. So I write my alert. So alert http from anywhere to anywhere. I will add a message in http like this. And then what do I need to do? I want to match on the http user agent. Okay, what is the keyword? So one way to do it is to go, not here, but come on guys, to go on Suricata readme.doc. Go there, look for, I don't know, HTTP, I don't know the keyword. Okay, no, that's not going to work. So one way to fix this is to fix this search, because is to just use Suricata and then use the list keywords option that will give you the list of keywords supported by your Suricata. So if I just now grep on HTTP, I will have a shorter list. And if I look at my list, I will see that I've got HTTP underscore user agent and HTTP.user agent. So I can refine a little bit more and do HTTP user agent. So here we have a content modifier, so the old style, and the next one, HTTP.user agent, should be the one we're looking for, the sticky buffer option, the keyword, sorry. So now I know that I need to use HTTP user agent. I can go back in my shell. It's a sticky buffer, so I put the keyword in front, then I do the content, and win HTTP, I think that was that. And yes, seed 1, revision 1. And okay, so I've got the first match. And now let's say that I want the URI. I got HTTP URI 2. So I'm going to say that it's a keyword. So I use HTTP URI and it was scene.png. Okay, so that's my first attempt on the signature. So now let's give it a try. So Suricata -t to test the configuration. And I want to specify my new file, win-http.rules, and I just want to output in data just for the safety, but everything will be on the screen. So here, as expected, I've got some issue. One is the HTTP URI is not correct. So because in fact, if we look at it, what was a wanted mistake? URI is a sticky buffer, so we need to use it the same way we've used the other one. So like this. So here, if I do one more typo, as you can see, on the rule keyword content, I've got another keyword, but another one. So by doing like this, I managed to iterate and find a way to write this signature. Then what I can do is test it. So -v to get the number of events, then I put my file. And okay, we got alert 0. And here, if we look in the other one, we got a match on scene.png, and we're going to match on win-http, and we've got what do you call that? Lowercase and uppercase here. So I need to fix that because in my signature, I just have lowercase. So one way to do it is just to add no case, this keyword, and then I should have a match by doing this. So, okay, we've got our first signature written. Okay, so you've got the first step. Now, there is another tool that is really useful inside Suricata. This is the engine analysis keyword, not keyword, command line option, that will analysis, to spell it correctly, that take just signature files, so with HTTP rules, -l in data. On this, we create a few new files. Maybe I can just clean data first and rewrite it. So in data, I've got some new files, role analysis.txt, which is really interesting. Okay, not really in this case, but it gives us an analysis of the syntax overall done by the engine itself. So in this case, we learned that we match an HTTP UI buffer, that we match the HTTP user agent buffer, and that we have a TCP rule without any flow or flag option. So this is not good for our performances, so we need to fix this. So if I want to fix this, I will need to go back and edit the signature to fix this. So this is to show you a little bit the loop. So you've got some -t to test the syntax. Where is my guy? It's here. Control F5. So I've got -t to test the syntax. I can analyze the one with engine analysis. I can list the keywords with this type of command, and it gives me some helpers. I don't need to just go on internet, but that's not really convenient. It would be nicer if all of this was available directly in my favorite editor. So the engine analysis, just to give a few words about this, because it's not a feature that is well known in Suricata. It has two main output files, the role analysis.txt that we have seen, and there is another one, the rule.json, that is really interesting to parse and find information in. What you will find inside this role analysis, you will have syntax error, you will have warning about potential performance issue. That's what we have seen in your example, and you also got some optimization information. So that's really a cool feature, but it's a bit complicated to jump from one shell to another to switch from between the editor and the syntax checking. So let's introduce the Suricata Language Server that aim at fixing this problem we have when we are writing Suricata rules. So what is the language server? The language server is an implementation of the language server protocol for one specific language. So the language server protocol is a standard that has been introduced by Microsoft to allow standard communication between IDE, text editor, and a language. So this is JSON RPC, and it will allow the editor to get information directly from the compiler or a tool developed by the team of the compiler, and get this information independently of the language. By doing this, it's possible to just code your support of the language server in your language server, of the language server protocol in your language server for your specific language. And by doing this, you get, if you implement correctly the standard, you get auto-completion, go-to definition, final reference, warnings. There is a lot of things that you can do. The web page is on GitHub, and it explains how to do that, and you've got some code example. Sadly in JavaScript, so I had to find something else. The language server support becomes more and more popular among editors. It's supported on a lot of editors. I think there's more for 50 editors that now support LSP. You've got Atom, VS Code, Sublime Text, Emacs, NeoVim, a lot of other ones. And with regard to the language support, there is really a lot of language. I did count more from 176 language implementation that are referenced. So this is a lot. And so if you have no LSP setup in your editor, it may be time to consider it. It's really powerful. There is even an implementation for LaTeX. For the one who know how the output of a compiler is looking in LaTeX, this is definitely something crazy. So there was no language server implementation for Suricata, so I did decide this end of last year to develop one. As I mentioned before, what I wanted to do is to have syntax checking, so we don't have to use the Suricata command line. I also wanted to have performance hints and auto-completion. So all of that is available in the Suricata language server. And it's available in your preferred editors. It has been tested with Visual Studio Code, NeoVim, Kate, Sublime Text 3. For Visual Studio Code, it has been tested in Linux and in Windows, so it works on both environments. If somebody has Mac OS or something like this and want to try it, let me know how did you do it and if it did work. It should, definitely should. Okay, so let's now do a demo of this. So let's first start with the code. So Visual Studio Code. Let's open a small Suricata rules. So here you can see that you've got the result display. So the color highlighting is not done by the Suricata language server. It comes from another component. And what we have here is the syntax checking that is done here. And here we can see that we got one warning. The rule inspect server and client side consider adding a flow keyword that has been added to on this point. We also got some information like here. It's an information about the fast pattern. So here we can see that Suricata did pick the fast pattern on the HTTP host on networks.com. I will get back into details about what is the fast pattern later for the one who don't know this notion inside Suricata. And so the good thing is that if you want to fix this guy, for instance, you need to add a flow. Here you can see that you've got completion and it's a pre-filter, it matches on the direction. You can in fact just jump on the documentation directly with one single click from the editor. So here I want to fix it. So I did flow, no, not flow, for example, to client just to test. And if I save this, it triggers an evaluation, and then now I've got no warning in my rule set, just the int is kept here. So this way you can really see how it works. So how it is to install this on Visual Code is it's got two Suricata extension installed. I've got a Suricata intelligence that have been developed and provide you the Suricata language server. And I've got the Suricata highlight that provide the highlighting of the Suricata signature syntax. The great thing about the Suricata language server is that it is working on any editor that supports LSP. So I think it was win-http.rules. So here we can see that what is looking like in our friend NeoVim. So got the same completion, same kind of feature. Here just the markdown is not as advanced as it is in Visual Code, so I just can click here on the link and get the same information. So this is working the same way on most editors. You get the same kind of result. There is some little difference, but it's really not a big thing. Yeah, so let's get back to the slide. Okay, so as I show you, you've got this in code in your Vim, it looks the same. So how is it done? The way it is done is that in some language server implementation, you've got people that implement the spec or the specification of a language and use that to analyze the text and the information sent by the editor on over JSON RPC. In the case of Suricata, there is no grammar available, and writing one can be complicated, even maybe impossible. So I did decide to use the Suricata command I did show you before to run this Suricata command transparently in the background, parse the result, and return them as a LSP message, so it will be available inside the editor. One of the big advantage of this is that even if you are coding your own, for instance, keyword, and you want to test this keyword, as soon as you install this Suricata and make it available to the Suricata language server, you will have this new keyword automatically discovered by your version of Suricata. So that's quite powerful. It allows you to switch from one file version to a 6 to your own version. So this is really interesting if you want to test with regard to your environment, what will be the result of the evaluation. The disadvantage, for sure, it is that you have to install Suricata on your system. Hopefully, on Linux, it's not an issue. You've got packages, you've got also some PPA or manual install, but it's quite okay to do. And on Windows, there is a package that you can install that is working pretty well in the README of the Suricata Language Server on GitHub. You've got explanation about how to install Suricata and make it work under Windows. So what is the availability? It's available under GPL v3. The sources are available on GitHub. It seems to be pretty stable, even if it's a young project. As I mentioned before, it has been tested on Linux and on Windows, and it works with NeoVim. It has been tested with NeoVim, VS Code, Kate, and Sublime Text 3. I think there is no issue in setting it with some other editor. And if ever you have a success, please open an issue on GitHub to mention it, or even do a merge request on the README to explain how you did do it, and so everybody can see how it is possible to use the Suricata language server with your favorite editors. With regard to the architecture, it is written in Python. As I mentioned before, the sample implementation are in JavaScript, so it was not for me. And I did use the Fortran language server that has a small code base that is written in Python. So I did use this as a base to work on the Suricata language server. So thanks a lot for this contribution by the NSEC. And it works by spawning Suricata command, analyzing the result. And for this part, I did use code from Sirius, the rule set manager that is used by and developed by the Stamus Networks. Because we already have testing capability of the rule set inside Sirius, so I did reuse this code because it provided me some parsing that I was able to use without rewriting it. So it did, by the way, detect the license because Sirius is GPL v3, so we'll add to have the Suricata language server has to be GPL v3 too. So yeah, now I've got some user that came back to me and told me, okay, that's nice, but what do we do with the warning? If you do not master Suricata detection engine, then in this case, it may be complicated to make sense of the warning that are produced by the tool. So the directionality warning, let's get a look at this one first. So let's just do one simple one. Alert TCP, any then message match stupid. And we do that. And I'm going to add. Okay, so if I do this, Oh no, role keyword flow content. Okay, oh, here I got a mistake. Let's fix that. Okay, so now I just have my my information about fast pattern on my inspect server side and client side. So this one is quite simple. In fact, if you say I'm going to match Toto in any TCP stream, which is exactly what this one is doing, in a lot of cases, you want to know if Toto is sent by the client or received by the client. So if you don't do this, you need to inspect one way of the streaming on the other way of the streaming. So you double the work. So to fix this, and you can do this in most cases, you can just say, I want the match to be done. First, we can do that on established connection because you want to be sure that the TCP has been the TCP session has been correctly established and that you are in a normal server and client exchanges, and then you got a few keywords like to client or to server, and you got also some from client that you can use to determine if you want to inspect one side or another. So if I save this, I see that now I've got no more warning in corresponding to this directionality issue. So if I get back to this, yes, that's it. The flow, the fix is simple. You just add the flow keyword and then you divide by 2 the analysis that is done by Suricata, because it just have to take care of one side instead of taking care of the 2 sides. Another one that I saw in the code and then discovered yesterday, and that is quite cool, is that if I do this kind of stuff, what is happening here? In fact, in the old time, there was no HTTP keywords, I mean, before Suricata 1.0. So a lot of people get used to write signature where they were matching the HTTP header directly on the stream. So this is definitely something you don't want to do, because as you can guess, if you just write this signature, then in this case, you will match on the page that explains that to do an HTTP request, you can use get Toto. A way so you got this warning that display that it looks like you are doing HTTP. So maybe you want to use something that is really used using the HTTP analysis feature of Suricata. So a way to do it is here we got a get, and then we get this URL on the website. So the way to fix it is to do something like, okay, I want the HTTP .uri to be, no, not like this, to be Toto, and I want the method, so HTTP method to be get. Okay, so if I do this, I will have just a hint about the fast pattern that is displayed, and I don't have any warning, and I've got a signature that is far better now, because what it is doing, it is first matching directly on the URI that has been extracted by Suricata, so it will match just on a small buffer, and also it will match on the method that also has been extracted by Suricata. So if ever you have some, you will never match inside the content of a pilot. You will just benefit from the analysis by Suricata. And by the way, it could be nice to also just say that you want to do this on HTTP, even if this keyword here implies the same. Okay, so this one is oh yes, okay. the mixed content one. Okay, so here, let's get back to my example and write another one. Yep. Okay, so alert HTTP, let's start with something a bit stupid like we have done before and do it like this. So here I will have the signature on duplicate signature. That's another warning. Okay, so I can. Oh, by the way, there is this thing that is quite fun too. If you have two signatures in the Suricata file, as you can see here, the signature with a newer revision is going to replace the previous one. So this one, in fact, is shadowing the other one. So let's fix that. And here I just have now application layer HTTP combined with row match. So it's almost the same problem as before, where we detect that it should be a match on HTTP. Here we've got HTTP being seen here, and here we just have a TCP stream match. So just to get to something else, we can do, what can we do? HTTP is already done. Okay, can do DNS for example. Okay. And do so DNS, what do I have in DNS? DNS query, that's perfect. Up. So here we've got the same. So it's not just HTTP. You can get this alert on DNS that look for in the UDP data /toto, and then look for get in the content of the DNS query. So here we've got the same issue. So definitely something to do to fix would be, even if it's not making a lot of sense in terms of signature, is to do something like this. So here we can see that we just have just the fast pattern information. So we did manage to get back to something that is working properly. Mixed content. Yes. Okay. Next one. Oh yes. Next one is what is remaining in the previous edition. We have information about fast pattern. So what is fast pattern for the one who are not familiar with that? So if you consider one of the biggest source of Suricata rules, which is given by Proofpoint, which is the ET-Pro rule set, we have more than 60,000 rules. If you take a speed that Suricata on Suricata-based product can do, 40 gig per second, it means that if you want to do a linear evaluation of the rule set, you have a budget of 0.05 nanosecond per rule, which is less from the cycle of CPU. So this is just not possible. You cannot match at this rate the 60,000 rules. So there is a lot of optimization inside Suricata in the detection engine to allow a faster match on this. The main one is the multi-pattern matching. The concept of the multi-pattern matching is to match multiple signatures at once by, in fact, matching a pattern inside one signature and checking that this pattern is present in one of the buffer analyzed by Suricata. Buffer can be the DNS query, it can be the HTTP URI, it can be a lot of things. Everything that is a sticky buffer, in fact, has a multi-pattern matcher behind. So what Suricata is doing is that when it starts, it loads the rule set, it finds out the fast pattern in the signature, and then it attaches the signature to the pattern. And then when you are doing an evaluation, you just see that, oh, I've got that data in the HTTP user agent. It's ready. What signature are you using the HTTP user agent? You don't even do that. You analyze the HTTP user agent that you got with regards to all the pattern registered on the HTTP user agent, so you got maybe 10,000 patterns or something like that. And then you pick the one that is matching, the ones that is matching, potentially it could be a multiple one, and then you just evaluate the signature that correspond to the match. So instead of doing 60,000 evaluation, you just do a fast pattern matching on this buffer, and then you maybe evaluate a few rules, and in a lot of cases, you just evaluate one single rule. So when you are writing signatures, it is really important to minimize the number of signatures that are using the same pattern, because if you have 10,000 signatures using the same pattern, then in this case, you will have, in a lot of cases, there's some other optimization, but in a lot of cases, you risk a linear evaluation of this signature. And as a result, you will have a real problem, and it will cause the detection engine to be so slow. And if the detection engine is slow, then in this case, the consequence is that you are losing packet. And if you are losing packet, you lose the visibility on the network and you lose the alert. So that's not what we want. So how Suricata is picking the fast pattern. So it uses, if you have multiple content match, it will use the longer match, or it will follow the fast pattern keyword instruction. So let's get a look at this. Let's say that we want to write a new rules on HTTP. So let's use this one. Ah no, first one was perfect. Oops, sorry. Okay, so I'm going to take this one, increase a bit. 4 should be good. Okay, so yes, I just have a duplicate. And for clarity, I'm going to comment the guy on the top. Oh, what did happen? Really? Okay. So I've got my first signature that is matching on the HTTP user agent. And then I want to do another match here, which would be content Mozilla, for instance. And no case two. What is happening? Oh, and I'm not lucky. I've got. Okay, I'm going to suppress this one for my example to work. So here, what will happen is that maybe I'm not lucky. Okay, like this. Sorry. So here I've got the fast pattern Mozilla that has been picked by Suricata, and the content. So the fast pattern will be done on Mozilla. As you know, Mozilla is almost present in all the HTTP user agent, which means that if we pick this, even if we are the only one to pick this fast pattern, we will evaluate on almost every HTTP request. So we will have these two checks to do. So this is really bad in terms of performance. So in this case, we want to fix this signature by just adding the fast pattern keyword and specify that the fast pattern has to be done on will be done on in HTTP and not on Mozilla. Yep. Okay, so that's it for the fast pattern. So if you are picking a fast pattern, choose the one which is really a differentiator in your attack. Force fast pattern if Suricata picks the longest pattern. So that's almost it for the presentation. I will just present you some linked work that may result in evolution of the Suricata Language Server. So it's a recent work that started a few days ago. So the rule.json that I mentioned coming from engine analysis is in fact really interesting. And I did use it to parse the ETPro rule set from some times ago. And so for that, I did create a Jupyter notebook. So it's a Python web interface that allows you to write code. And I did parse the JSON, build the data structure, and then do an analysis to see what we have. So this is this shell here. Yep, okay. So, oh, well, maybe I can zoom a little bit. Yes, should be better like this. Okay, so Suricata rule set analysis. So I just got the rule.json produced on the full ETPro rule set. I did just do a parse on the entry are looking what? Okay, the entry are looking like this. So you've got the signature, you've got information, a lot of information, like you got the list of matches. So it's really a valuable source of information. And the only thing I'm currently using is the, the NPM information here that tell us that in fact the payload, the multi-pattern matching, so the fast pattern, is done on the payload, so directly on the TCP streaming in this case, and what it is looking for is this string. So this is this pattern is attached to the payload. Then what I've done is just build a simple array with the extracted information about the pattern, the buffer, and stuff like this per signature. Next one, I have use a Python library that is networkix that will allow you to build a tree where in fact I will link the SID with the pattern and the pattern with the buffer. This way I will know how much signature are attached to every pattern, which will give me information about the reuse of pattern inside this rule set. Then I just get this, and I will extract all the nodes that are inside the pattern where their degree is superior to 20. So by that we mean I want to find all the pattern where I have more from 19 signature attached. This is the result. And I was really surprised by this because we can see here that we got this pattern here method that has more than 3,000 signature attached. So that's really a lot, which means that if you got this matched, you kind of have a lot of signature to evaluate. Some other one, funny one, like Let's Encrypt Authority, which is a fast pattern that is more and more common currently in TLS. And yes, that's the list. And then we have, I just wanted to display this, so I will pick this pattern and will filter my table to just display the signature. And what we can see here is that most of these signature that are using this pattern here are coin miner signature that are available in the system. That are available, sorry, in ETPro. Yep. So maybe there is something to do, or maybe if you have performance issue and see this eating a bit, maybe you should do something on the silent bell. Yep. Yep. Okay, so what is the feature of SLS, the Suricata Language Server? There is a non-limit. The fact that we are running Suricata commands behind, some of them are taking a bit too much time, so don't open 60,000 signature at the same time. It will be a bit too big. And so we currently have a limit, I think, at 1,000, if I remember correctly. And with regard to the evolution, I think that this first pattern usage I show you in the previous one could be useful, because if you can point the user and say, okay, maybe you don't want to use this first pattern, it's already used. a lot, so that could be interesting. Another thing that may happen is to link that with performance analysis. Suricata has a really nice profiling running mode, not profiling option, not a running mode, that allow you to know what is the time spent on each signature. This is quite interesting in this case because we could feedback the performance of during the edition. Maybe a bit complicated. I don't know if we will manage to do this, but it could be an evolution of a software. And to provide also a better completion, it is already working, but there is some improvement that can be done. It is working well for the keyword, but for the first part, it is not done the alert any. This part is not correctly well covered, but that's a simple part, so that's not too bad. So conclusion, it's easy to use, it's easy to install once you've got the instruction for your editor, and it gives you a lot of information. I would just like to thank the Suricata developer for all the help, the test, the engine analysis. It's really helpful, and it allowed me to build this tool quite easily. Yes, feedback and contribution are welcome. If ever you manage to make Emacs work with SLS, then in this case, you may want to warn me on GitHub so I can add this information or with the instruction. That would be really lovely if we can have this kind of feedback on any idea also are welcome for sure. So it's now question time. Do you have any questions?
I think there was just a couple of questions about getting it to work with other editors like Emacs and Notepad++, but it looks like there's been a little bit of help there.
Okay. What I've seen, I discussed a little bit about Notepad++. There is some plugin that provide LSP compatibility. Not working. I did not know about final. It is working.
Okay. A couple of questions about slides. So I assume, Eric, you'll be fine to share those. If so,
no problem. Yes, I will export it on Josh. I'll let you share them with the attendees.
Okay.
No problem.
Yep, we will. We typically put an entry on the suricata.io website.
Yeah, sure.
And then we'll hang those slides there as a PDF or whatever. So those will be downloadable. Once we get those posted, as well as the video here on YouTube, I'll put a notification out in the forums and also on Discord. So you'll be notified, and Twitter as well. So you'll be notified. Everyone will be notified, multiple channels when all the content is available.
Yeah, sure, no problem with that.
Okay.
Yeah, I'm sorry for my French accent. I see a remark on the chat. I'm really sorry. I try my best, but when I explain things, it gets away. Okay.
Yeah, I haven't seen any other questions, so we can hang out for just another little bit of time if see any more questions come in. Otherwise, I believe we are nearing the end.
Okay.
Question about the Jupyter Notebook, if you're willing to share that. I don't really have a way to do that, so that's up to you, Eric.
Yeah, we've got a project. I think it will end up in a repository at Stamus.
Okay.
And I will ping on Discord when it is available.
Okey-doke. Well, I think
can
what
you
we'll
hear
do
me?
then. Yeah.
I have a question. Actually, it's a suggestion. Would it make sense to have a hands-on session with the Jupyter analysis that you did?
We can do that. Definitely. That's Jupyter is really cool, and we can do a lot more from that. So yes, that can be interesting.
Cool. Thank you.
All right, I've made a note of that, Eric. I'll be following up with that. once it's made it to one of my sticky pads, it's semi-permanent. It's well on its way to a proper project in Asana.
Okay.
Let's see, integration for Mac OS based editors.
I did not get any feedback about people managing to do this. It should not be too complicated. Don't hesitate to come on Discord. Stamus Networks has a Discord that is dedicated, and we have a channel dedicated to the Suricata Language Server. So if you want to come there to ask a question, we will be happy to answer, or you can just open an issue on GitHub. That works too. If you have questions, try to make it work and you don't manage to do it. But it should be fairly simple.
Cool. Okay. Okay, now I will stop the recording.
Okay.